All right, so everyone should have this in front of them, whether it's filled out or not. This is what I gave out Thursday when I wasn't here to my algebra students. So some of you, this is your first time seeing it. I think it's an easy enough lesson that you could do it on your own, but we have time in math lab. Why not do some together? So it's important that you know how to simplify radicals because we're about to get into the quadratic formula in algebra, and you have to know how to simplify the radical. You also need to know how to do that for your higher level math as well. So might as well get it out of the way with this like add-in one. So first there's the parts of a radical. So when I talk about a radical, I'm talking about this symbol. What is it also called, that symbol? A square root symbol. Now, it's only a square root symbol if it has no little number right here, or if that little number is 2. All right, usually we don't write the 2 there. If it's not written, it's assumed to be a square root symbol. But that little number is what we call an index, because we could do like a cube root, we could do a 5th root, like things like that. So what are square roots the opposite of? No. So like if I did the square root of 49, what's that? 7. And then 7 squared equals 49. So these squares and square roots are opposite of each other. So then when we get to cube roots and stuff, so like if I asked you what's the cube root of 8, the answer would be 2. And guess what 2 cubed equals? 2 times 2 times 2? 8. So like those would be opposites of each other. So whatever little number there is called an index. Usually it's 2 if it's not written. And then the number underneath the radical symbol, usually I just call it a base, but it's actually called a radicand. All right. And then if there's no index, it's assumed that the index equals 2. All right, so questions on the different parts. It's just some vocabulary so you know what I'm talking about. Yes. I'm sure you're back in 5 minutes. Okay, so before we get into how to simplify, I think the simplifying is easy. But it's helpful to kind of know what your perfect squares are. So, like what's 1 square? So if I take the square root of 1, I get 1. All right, what's 2 squared? 3 squared. 4 squared. Now keep doing that all the way up to 12, like 12 perfect squares. We have 4 of them already. Let's see if you know them by heart. If you need to use a calculator, figure them out, then fine. But it's helpful to know at least the first 12 perfect squares so that you can recognize them and save yourself some work. So compare your list to mine. Those are the first 12 perfect squares. So 1, 4, 9, 16, 25. What's the square root of 25? What's the square root of 36? Square root of 49? Square root of 64? Square root of 81? Square root of 100? Square root of 121? And square root of 144. Okay, good. Now, granted, you kind of don't need to have those memorized, but it would be helpful if you did. Regardless, you can tell if something's a perfect square or not by pressing the square root button in your calculator and typing that number in. So like 144, I know is a perfect square because it gives me a whole number when I type it in. All right, now the whole purpose of what we're gonna do is what to do if it's not a perfect square. So like 145 is not a perfect square, but we don't use that decimal because it's not exact. All right, so for example, I told you that squaring and square rooting cancel each other out, right? So I have, for example, if I did this times the square root of 145, all right, I should get 145 because it cancels out. If I were to take that decimal and round it, even if I type in that whole decimal that it gives me, it will not give me 145. It'll give me a decimal. So, for example, so I'm just typing it in exactly how it is. Right? I typed it in. Oh, it did give me 145. Oh, that usually doesn't happen because this is actually a decimal that goes on forever and never repeats. So it's really actually not possible to put the entire decimal in a calculator. That's why it only shows you part of it. All right, but what I was trying to show you is that if you round it, so say we rounded it to 2 spots, 12.04 times 12.04, I'm not getting 145 exactly. So we don't want to use the decimal approximation. We want to simplify the radical, which is what we're going to do. All right. So these ones are perfect square roots. I don't necessarily think we need to practice them. We could do the fractions real quick, just because I know you guys love fractions. How do you take the square root of a fraction? So like, what's the square root of 1/16? All right, no clue at all. All right, so here's how you do it. You take the square root of the numerator and the denominator individually. So what's the square root of 1? What's the square root of 16? So that's my square root of 1/16, is 1/4. So try that with 8 and 9 real quick. All right, what's the square root of 9 over 100? Don't yell it out. Table 5, what's the square root of 9 over 100? All right, 3/10, class, agree, disagree? All right, good. So we square root numerator and denominator individually. And if I were to multiply them out, I do get 9 over 100. So good. Table 6, what about number 9 with the square root of 25 over 49? 5/7. So questions, comments, concerns? All right. So to hear crickets anymore than the square root of fraction. Just side note, number 4, or like 4 through 6 actually. What operation is implied if there's like no plus, minus, multiplication, or division sign written? So maybe let me just this right here is 18 times the square root of 4. So if you see it written together like that, it's technically times each other. They don't put the multiplication sign there, but that's what they mean. This isn't an index for the little number times that. What's the square root of 4? 2, and then 18 times 2 is 36. So that's how you would do those if you need to, but moving on. All right, so whole goal of today is to simplify non-perfect square roots. If you liked in middle school when you made factor trees, then that's how we are going to simplify these. So it's kind of like a safe space. I feel like my students usually really like this lesson. But if you need to simplify a non-perfect square, I wouldn't use these steps right here. I would use what I'm about to tell you. I would break it down into its prime factors. So what are two numbers that multiply to 24? 6 and 4. You could do other numbers. It really doesn't matter though, because you're gonna get the same prime numbers regardless. Are 6 and 4 both prime? All right, maybe we don't know what prime means. So prime means that it doesn't break down any further other than 1 in itself. So are the only factors of 6 and 1? So that means 6 is not prime. I'm going to break it down to 3 and 2. Are 3 and 2 prime? Yes, because they don't break down further other than 1 in itself. It's 4 prime. So what does 4 break into? So at the end of my factor tree, are these all prime numbers? Okay, yes, they are. Because 3 and 2 don't break down further except for 1 in itself. Now, don't look at the non-prime numbers. I'll cross them out just so you're not confused. Only look at the prime numbers. I want you to think of the radical symbol as like a little jail cell. And the rule for the jail, because it could be different depending on what the index is if it's a square root symbol, you need a partner to escape the jail. So in my prime numbers, I'm going to look for pairs of the same number. Do I have any? What is it? So I have one pair of 2s. They get to escape. You write it once for each group, so they get to be outside the jail or the rat. Do I have any prime numbers left over? 3 and 2. If I have multiple pairs, I would multiply them together. If I have multiple numbers left over, I would multiply them together. That's 3 times 2. So my simplified radical for the square root of 24 is 2 radical 6. I usually count. Or 2 times the square root of 6. But those are equivalent. Questions on that? All right, if you want to see if your answer is equivalent to the problem. So for example, I did this on a test because I forgot how to simplify radicals. I think I was supposed to pick from some options. So I plugged in my options. If my square root is supposed to be of 24 and I type in my radical version of it, it should give me the exact same decimal. And it does. So that's how you can check to make sure that you wrote it in the right form. So questions on that process? No. So that's a good question. Let's see if there's one on here that would be like that. So I don't see one on here that would be like that. But Mia asked a good question. She said, will there always be a number on the outside? Not if it's prime. So, for example, if it's telling me to take the square root of 17, maybe I try to make a factor tree. Are there any numbers that go into 17 other than 1 and 17? So then my simplified radical is really just that, because 17 is prime. All right, I do want to show you, well, maybe later with that. Do you want to see one more, or do you want to try one? Okay, see one more. Which one do you think looks hard? 15, all right. So 15, two numbers that multiply to 175. 5 and 35. Okay, let me just double check that. I do know since it ends in a 5 that it's divisible by 5. So yeah, 5 and 35 work. Could also do like 25 times 7. That works. But yeah, 5 and 35 is 5 prime. Yeah. So that one's good. Don't break that further. It's 35 prime. What does 35 break into? Am I down to all my prime numbers? Yes, so don't look at your non-prime numbers, cross them out if you need to, like, that has to be broken down, that was broken down. Only look at the prime numbers. Do I have any pairs? Where does the 5 get written then? On the outside, there's 1 time for each pair. What do I do with that leftover 7? You will not multiply it. You will put it underneath the radical, because since it didn't have a partner, it doesn't get to escape. All right, so 5 radical 7 is how you simplify that one. Question on 15. Okay, so I'll have you guys try. I don't know what you would have had from the video if you did it. So I want you guys to try 13 and 14. Usually after. Yeah. Okay, so this is my factor trees, and even if you chose different numbers for what multiplies to that number, as long as they multiply to that number, it shouldn't matter. You should still get the same prime factors at the end. So if it helps, cross out your non-prime numbers. That way, you're only looking at the prime numbers for any pairs. All right, if you have a pair of the same number, you get to escape the jail. If not, then you're stuck. So questions on that. 13 should be 3 radical 7. Okay. I will. After this one. The questions on 13. Okay, so 14. Here's my factor tree. I chose 9 and 10. Regardless, should still break down to 3, 3, 2, and 5. And looking for pairs of the same number. I only have a pair of 3s. So for each pair, write it once outside of the radical. Left over, I have a 2 and a 5. I'm multiplying together. So if you have like more than one of either side, multiply them together. Since they don't have partners, they go under the radical. 2 times 5 is 10. So questions on 14. All right, Gabe requested number 11, so let's see that real quick. 2 numbers that multiply to 48. And they're not prime, so what goes into 8? 4 is not prime, that becomes 2 and 2, so now 8 is fully broken down. 6 is not prime, so what goes into 6? 2 and 3. So quite a few prime numbers. Don't look at the non-prime numbers, that's why I'm crossing them out. In my prime numbers, do I have any pairs? I have 2 pairs of 2. So for each pair, you write it once, and if you have multiple on either side, then you multiply them together. So for each pair, I write 1, 2. So 2 times 2, which will simplify. And I have a leftover 3 that goes under the radical. It didn't have a partner, so it doesn't escape. What's 2 times 2? So for number 11, it would have been 4 radical 3. Questions on 11. All right, what happens if you make a factor tree and you have no numbers left over? What does that mean? What is it? Can't quite hear. It's done. Kind of. If what happens if I make a factor tree and I have all pairs of numbers, nothing left over, what do I do? You multiply all of them on the outside. Do I write anything under the radical? No. And if that happens, then it must be a perfect square that you just factored. So that's why if it's a perfect square, it's kind of nice to just know your perfect squares so that you don't waste time making a tree for it. So for example, if I did 16. Made a factor tree for that, so 8 times 2. 8 breaks down into 4 times 2, that breaks down into 2 times 2. So only looking at my prime numbers, I notice that I have 2 pairs of 2s and nothing left over. The rule still holds true. All right, for each pair, you write it once outside of the radical and multiply it together, so 2 times 2. Nothing inside, so there was no leftovers. So what's 2 times 2? And that's the square root of 16, isn't it? So you don't need to make a factor tree for that, but if that happens, that's because it was a perfect square. Yes? Okay. So let's see. 2 numbers that multiply to 72. Okay, good. 9 breaks down into, and 8 breaks down into. All right, 4 breaks down into. Did you see where the mistake was made? Yeah. Okay. So then if anyone else cares to see it, cross out your non-prime numbers, only look at your prime numbers. For that one, I have a pair of 3s, a pair of 2s. So a 3 escaped, a 2 escaped. We'll multiply them together on the outside. Inside will be what? A 2. That lonely 2 that didn't have a partner. So then 3 times 2 is, so for 12, it would have been 6 rather than 2. Questions on that? Okay. Let's see on the back. I feel like with all those extra questions, I feel like we covered what we need to. So that should make algebra a bit easier. We can do cube roots tomorrow. So if you did not take notes on that sub day and submit them, you could submit these notes and I'll give you credit. It'll be like a grade in algebra and math lab, but it's just the one thing. So that was a grade in algebra. The practice for it, I'll give you some time to work on tomorrow after we go over the cube roots.